Have you ever wondered how a dirty ice cube in Alaska could affect us right here in central Pennsylvania? It sounds impossible, but that connection is real. Permafrost, the frozen ground beneath our feet starting to thaw, and when it thaws, it will have a serious impact on our planet. You might ask me, how is that possible? Well, to find the answer, we have to travel to the coldest part on Earth, places like Siberia, Alaska, and the Arctic, which you could call the true home of permafrost. These regions are now warming 4 times faster than the rest of the world. That's enough to start the thaw, and this is definitely something we should be concerned about because permafrost holds about 1500 billion tons of carbon, almost double what's already in our atmosphere. When it thaws, this trapped carbon is released as greenhouse gases, such as methane and carbon dioxide, which speed up global warming. And that extra heat melts even more permafrost. As you can see, it becomes a loop that keeps feeding itself. So it's really important to understand what's happening in places like Alaska, where permafrost is changing rapidly. But the big question is, how can we predict permafrost thaw? Scientists often rely on remote sensing to monitor permafrost, but there is a catch. These techniques often struggle to see what's happening beneath the surface, where the change truly begins. And that's where my research comes in. At Penn State, home to one of the world's largest materials research institute, we look at permafrost as a material, something that can be studied, measured, and understood at a fundamental level. When we send electrical signals through permafrost, we can understand how different states of water behave during the freeze-thaw cycle. What I found is that the lower frequency signals reveal bound water behavior, while higher frequency signals come from bulk water. This is something climate experts have been trying to find for years, because if we can track the water movement inside permafrost, we get an idea about how it will respond to climate change. It's really important because when permafrost thaws, it doesn't just change the Arctic, it changes the entire planet. And by linking our findings to remote sensing signals, we can predict those changes before it's too late. That day is not too far when insights from my research can guide better climate predictions and smarter policy decisions to save our planet for the future generation. Thank you.